folks. Currently I don't have a controller, so today I'm going to start doing something about that. Now, the requirements I have are basically just to run a short length of test track. So to do that I want speed control on 12 volts, preferably pulse width modulated, because that can give better slow speed performance in some applications. And I also want it to be programmable because I don't have a rolling road or anything like that. I don't have a round loop layout either, so I currently have nowhere to run in locos. So what I want to be able to do is have a short length of test track where I can just sit a loco on it, highly technical drawings here, and just have it shuttle itself forwards and backwards without any intervention, so that it can just run in its mechanism. So, in order to achieve the programmable part, I'm going to be using an Arduino. So, let's call that A. And to do the driving or the pulse width modulation, I'm going to add a separate pulse width modulated controller. To power the whole thing, I need a power supply of some kind. So, I'm going to give it a plus and minus. And we have a track. So all I really need to do is source the bits for this. So for this I'm going to use the cheapest Arduino I can find, which is a Nano Every, which is a new one they've just brought out. So we'll give that some power. We will also have to power our pulse width modulated controller and give it a couple of analog outputs from the Arduino, which does pulse width modulation by default. That can then get connected up to the track, and we can play around with the code on here to make it do whatever we want in theory. Now, part of the automation that I want to add is a thing called a light dependent resistor, and I want to be able to add that under the track and connect it back into the Arduino so that it can detect when a train has reached either end of the test track and reverse the direction of the motor. So, first port of call is to put all this on a breadboard, which is a bit of kit electronics people use for prototyping stuff. So let's see how I get on with that. So here we have the motor controller set up on a breadboard. We have the DRV motor controller, an Arduino to run it, connected to the laptop, and then the motor itself at the end. We also have a power supply coming in here just providing 12 volts. So all the components are powered off this 12 volt rail on the breadboard here, and then the motor controller is doing pulse width modulation to run the actual motor. So at the moment it's just running a simple program to shuttle this motor, ramp it up to full speed forwards for 5 seconds, ramp it back down, and then the same thing in reverse. So I've been testing this motor for about half an hour now. It's not heated up significantly, which is good news. I've tested a few different types of motor, like this small brushed DC one. I've tried some cordless motors, some larger brushed DC ones, and it's coping fine with those so far. So the code to run this is a very simple little bit of software over there on the laptop, but we'll go into that in a bit more detail later on. So the next port of call, I think, is to put all of this stuff onto a proper circuit board to make it nice and compact and neat, and then we can look at getting into some more complicated software and different inputs and outputs and so on. Now we've got a slightly different configuration of the test controller. So I've wired it up to short section of track instead of just having it on the motor. We have a variable resistor in here with a screwdriver in the end so I can control the speed, and I've wired in a light dependent resistor, which you might be able to see between the tracks down here. So I'm aiming to test some of the automation of the system, and basically whether a little loco like this can set off the light dependent resistor, and then we can use that as the basis for a shuttle mechanism essentially. So I'm really hoping this works, because otherwise my loco is going off the end here somewhere. So let's give it a go. the wheels aren't particularly clean and the track isn't particularly clean, but you can see turning it either way makes the logo go either way, which is nice. And let's see if it stops when it gets to that resistor, which it does. So the resistor is here, and it stops. So I've finalised the PCB for this. I've got those on order, so hopefully they'll be coming soon, and I can transfer this nice big mess of wires onto a nice neat PCB.